So today we are going to see a double circuit line with vertical arrangement. So I have considered three conductors. So I'm considering 6 conductors. So it is a double circuit line. So I am having 2 conductors per phase. A dash, B dash, and C dash I am considering, and I am considering the radius between these two will be 2 meter. So the distance between all these conductors will be 2 meter for all the case. Right? So the distance between these conductors is 2 meters. So the radius of each conductor. So radius of each conductor so I am considering it will be 12 millimeter. So we have to find the inductance per kilometer per phase. So we have to calculate. So the inductance of double circuit line for this horizontal type arrangement. So you can see the 6 conductors which will be arranged horizontally. So each distance between the conductors is 2 meter, and the radius of the conductor will be, I am considering 12 millimeter. So first we have to compute the R dash value. So R dash value, so the formula for R dash is 0.7788 R. So R I am considering 12 millimeter. So I will convert that into meter. So 0.7788 into then radius. So 12 millimeter I am converting into the meter. So if you compute this value, so you will get 0.0093456. Right. So next we have to find the inductance value. So before finding the inductance, so we have to compute ds as well as dm for the conductor. So ds value. So formula for calculating ds. So formula for calculating ds is cubic root of dsa dsb and dsc. Right. So first we have to find dsa formula. So we can have two formulas. One will be fourth root of so d aa, so d a dash, so d a dash a, then d a dash a dash, or we can write square root of r dash d. So both are same. So this both formulas are same. So d is distance between conductor a to a dash. So the d are here. So distance between a to a dash. So we have calculated r dash value. So r dash value is 0.00934. and D. So we have to calculate distance between A to A dash. So distance between A to A dash. So what is the distance between A to A dash?
6 meters.
6 meters. So 2 plus 2 plus 2. So we will have 6 meters. So we will have 6. So if you compute this, 0.2368 meter. So similarly, we have to find the SB. So SB, we have to find distance between B to B dash. So what is the distance between B to B dash?
Same 6 meters.
6 meter. Then what is the distance between C to C dash? Again, it is 6
6 meters.
meter. So there will be no need of computing D, SB and SC. So all the values will be same as 0.2368. So once if you compute DSA, DSB and DSC, we can compute DS. So it is a cubic root of DSA, SB and SC. So all these values are same. So SA, SB and SC values are same. So we can get DS value will be same. So DS, it will be 0.2368 meter. Now we have to compute DM. So DM again it is cubic root of. So M we can say it is a mutual distance. So mutual distance it is D AB BC and CA. So we have to compute first DAB. So DAB. So again I am taking root. So I am consider DAB, then DA dash B, DAB dash, then DA dash B dash. So we contain 4 terms in the inside the root. So we will put 4th cubic root. So we have to find the distance between. So D conductor A to B, A dash B, A B dash and A dash B dash. So first distance between A to B. So what is the distance?
2 meters.
2 meter. So 2 meter. Then we have to compute the distance between A dash B. A dash to B. So what is the distance?
4 meters.
4 meter. Next is we have to compute distance between A, B dash. So we will have 8 meters, 2 plus 2 plus 2 plus 2, 8 meters. Then distance between A dash and B dash, it will be 2 meters. So 2 into 4 into 8 into 2. So this is the values. So once if you compute, so the DAB value will be 3.364 meter. Similarly, we have to find DBC as well as DCA. So DBC, I will find. So 4th root of. So D, BC, D, B dash C, D, B, C dash, then D, C dash, B dash, C dash. So we have to find the distance between D for conductor BC. So just to go to the diagram and find the distance. So B to C is 2 meter. Then B dash to C dash is 2 meter. Then B to C dash, it is 8 meters. Then B dash to C, it is 4 meters. It will be like similar case. So 2 into 4 into 8 into 2. So you will get same answer. It will be 3.364 meter. So now we have to find DCA. Fourth root of, so DCA, D C dash A, D C A dash, D C dash A dash. Right? So we have to find the distance for CA, C dash A, and all those things. So equal to fourth root of. So just to go to the diagram. So we are going to find a distance between C and A conductor. So distance between C and A. So it will be 4 meters. Similarly, C dash to A dash, it will be 4 meters. Now, D C into A dash. So it will be 2 meter, and C dash to A dash. So it will be 4. Then C dash to A. So 2, 2, 2, 2, 2. So totally 10. So you can find the distance. So CA, it will be 4, C dash A 2, CA dash 10, and again it will be 4. So if you compute DCA, it will be 4.229 meter. So once if we found all these things, we can find dm. So cubic root of, so AB, BC, and CA. So all the values we know. So AB, BC value is 3.364, and DCA value will be 4.229. So once if we found, so we can find dm. So the value for dm, it will be 3.63 meter. So once if we found dm and ds, we can easily found inductance value L. So L formula for finding 2 into 10 power minus 7 ln of dm divided by ds. So the unit for this thing will be Henry per meter. So we have calculated dm and ds value. So we substitute in this formula, ln of dm will be 3.63, ds will be 0.2368. So if you find out the answer through calculator, so you will get 0.546 millihenry per kilometer. So this is the inductance value for this problem. So the horizontal arrangement is somewhat easier than the vertical arrangement. So in vertical arrangement, we have to find some conductor distance through some triangle methods. So here there will be no such issues. So we can straight away drag the values between conductors easily by looking into the picture. So this is a double circuit line. Suppose, so the double circuit line has bundled conductors, right? So suppose the double circuit line has a bundled conductors. So I am having a bundled conductor in a double circuit line. Right, so I will consider the bundle spacing. So bundle spacing, again that bundle spacing D will be 40 centimeter I have considered. So where I have to change, so where I need changes, yeah. So the change here is, so instead of DAA and DA dash A dash, so we have substituted R dash. So instead of that R dash, so we have to compute a certain value, again DAA value, that will be root of R dash D. So R dash value is value. What is the D value? So this value will be equal to bundled spacing, right? So just wait, I will draw this same problem here, then we can find. So I'm considering the bundled conductors. So A, B, C are bundled conductors. So A, B, C, A dash, B dash, and C dash. So the distance between will be 2 for all the case. Radius of the conductor I am considering 12 millimeter, and the bundle spacing. So bundle spacing, I am consider it will be 40 centimeter. So if we consider R dash, so same value. So what we have find out here, so it will be 0.00934 meter. So R dash will be 0.0093456 meter. So we have to find out ds value, right? So ds value, so we know it will be cubic root of dSA, dSB, and dSC. So we have to find out dSA. So dSA, so I will write this formula, fourth root of, so DAA, so DA dash A, DA dash, and DA dash A dash. So we have considered, so AA will be R dash value, and A dash A will be the distance between conductor A to A dash. So this will be D, and this will be R dash value. So if it is a normal double circuit line without bundle conductor, so we consider this and we find out square root of R dash D. So R dash we can find out. D is distance between conductor A to A dash. Right? So or another formula we can write dSA will be equal to root of R dash D. So here D will be distance between conductor A to A dash. Right. So we cannot, because of bundle conductor, so we cannot straight away substitute R dash here. So instead of R dash, we are having bundled conductor at that place. So we need a bundle thing. So DAA value or DA dash value or this R dash. So instead of R dash, we have to find out some value. So that I can write because of two bundle. So we have the formula square root of R dash D. So D is bundle spacing. So here D is bundle spacing. So we know the R dash value. So 0.009346. So bundle spacing, it will be 40 centimeter. So if you do that, so you will get an answer. So can anyone tell what is the answer? So the answer for this DAA dash R dash, what is the answer?
0.0611.
So 0.0611 meter. So we can find DSA value. So DSA value will be square root of R dash D. So this DAA R dash we have find out. So 0.0611 into D. So D here, so that is distance between conductor A to A dash. So what is the distance between conductor A to A dash? 6 meter. So can anyone tell what is the answer for DSA?
Zero 0.60547.
0.60547. So D, SA, SB and SC value will be similar as we have discussed in earlier. So I consider this as DS value. So there will be no change in the DM value. So we can straight away find inductance. So DM value, so we can find out earlier, that is 3.63. DS value, so 0.605. So what is the inductance value?
0.358 millihenry per kilometer.
So the answer for that will be 0.358 millihenry per kilometer. So there will be no change in the dm value. So ds, if we are not having bundled conductor, so ds value will be 0.2368 meter. So similarly, inductance value will be become 0.546 millihenry per kilometer. Suppose if we are having conductor with bundle arrangement, or if you are having bundled conductor arrangement, so the ds value will be 0.605 meter. So the inductance value will be 0.358 millihenry. Right? So from this, what we can conclude? So we can conclude such that, so if we use bundled conductor, so the inductance of transmission line will get decreases. Right? So if we use bundled conductor, so the inductance of transmission line will get decreases. Or in other words, if we go for bundling arrangement, the self GMD or the self GMR, that will be increasing. So once the self GMD or GMR increases, so automatically your inductance value will be decreasing. So from this problem, so we can conclude that if we going for bundling arrangement, so self GMD will be increased, that will cause us the inductance will be decreased one, right? So because of decrease in inductance, so we can say reactance, so X will be gets reduced per phase. So this is what we can conclude while if you solve problem with without bundle and with bundle conductor arrangement.